Now let's do an example of Coulomb's law for surface charges. I'm again going to use my simple XY case because it does make it easy to explain how Coulomb's law is done here. So here's my X and Y, and let's say that I want to find the electric field out here at a point. The electric field is going to be at X is 6 and Y is 3, and I'm going to have a surface charge right here where my rho s is given as x times y coulombs per meter squared, and it's going from x is 0 to 2 and y from 1 to 3. Now I can tell that this is a surface charge because it's given in meters squared, and I can see that it varies in x and y, but I'm going to define that as my xs and my ys variable because those are on the source. It's not the point where I want to find the electric field, it's at the source. So there's my rho s. Well, now what I'm going to do is the same thing I've done for all my cases. I'm going to define a coordinate system and a convenient origin. I don't know why that happened to be particularly convenient, but it looks good enough to me. So there's my rho s with a convenient origin. I now need to draw rs, which is the vector that goes from the origin to the source. Well, there are a lot of places on this source, so what I'm going to do is break it up into little pieces. Each of those pieces is a little ds term, and I'm going to draw my rs like this from my origin to that piece of the source. Rs in this case is going to be some value xs in the x direction plus some value ys in the y direction. And I know those are going to vary xs from 0 to 2 and ys from 1 to 3. I then need a vector yp which goes from the origin to the point where I want to find the electric field. Rp is going to be 6 in the x direction plus 3 in the y direction. And then this vector rsp, which goes from the source to the point, rsp is going to be rp minus rs, and that is going to be equal to 6 minus xs in the x direction plus 3 minus ys in the y direction. In order to find its magnitude, I will square each of these terms and add them up. Oops, that's a negative sign right there. Minus ys squared, and take the square root. That right there is the magnitude of the vector from the source to the point. I also need the unit vector rsp, and that is going to be the vector rsp divided by, it's going to be the vector rsp divided by its magnitude. The electric field, the differential electric field at point P, is going to be dq. dq in this case is going to be rho s ds because it's a surface charge. We're going to divide by 4 pi epsilon, the magnitude of rsp squared, and the direction is the unit vector from rs to rp. Now adding up these sources means that we're going to be integrating over a surface. So the electric field is going to be the surface integral of dE, and that's going to be the surface integral of our rho s, which is xs, ys, our ds, let me handle that in just a minute, divided by 4 pi epsilon naught, magnitude of rsp squared, and this unit vector rsp. Now let's figure out what ds is. We want to be adding up all of the points right here on this surface, so this is going to be dxs, dys, xs is going to go from 0 to 2, and ys is going to go from 1 to 3.